All right, hey everybody, time for Cloudy with a Chance of Learning, and we've got a fun topic today.
Yeah, we often talk about how our classroom talks are kind of like puzzle pieces for one another, right? We talked about UV index, why is it important for our health here in South Texas, but we'll be talking kind of about the sunlight as well. So that's definitely something we'll dive into today.
Yeah, this is actually this Cloudy with a Chance of Learning is going to answer that big question. Why is the sky blue? And whenever somebody asks you that, whenever you're out maybe in class or maybe if your parents question you, hey, do you know why the sky is blue?
Yeah.
You'll be able to answer them and say, oh, it's because of what we're going to teach you today.
Exactly. And the big word I think to take away from this talk, and this is a little tease, but scattering. Remember the word scattering.
Yeah, that's the big talk today. And this classroom lesson is going to be all about sunrises and sunsets, but there's a lot of sub lessons, I guess, within this one.
Yeah, clouds play an important role. Saharan dust, pollution, that all plays an important role in how vibrant our sunrises and sunsets will be, especially right here in San Antonio and also across our viewing area. Yeah. I noticed that we have Sabrina saying hi. We have Matthew from Civilo joining us. He says, sorry I've missed the classes for a while. No worries.
Yeah, no worries, Matthew. But we love it whenever you're in the classroom, and we're happy to have you with you. Happy to have you with us today. Oh, Ollie, it's okay. Ollie's whining a little bit.
He just wants attention as usual. Okay, so let's kind of dive into this topic. Again, we'll be talking about the big word scattering, right? And sunrises and sunsets. Scattering is so important when it comes to talking about the sunlight. So sunlight appears white, right? But it's actually made up of all sorts of colors.
Okay.
So remember the saying Roy G. Biv, right?
Yeah, the rainbow.
Yeah,
the rainbow. In order. Roy G. Biv.
So remember that. You may have heard that before, maybe in your science class or one of your classes, but Roy G. Biv, that's, the best abbreviation to really memorize the rainbow.
Yeah, and it's red, orange, yellow, green, blue, indigo, violet. I had to make sure that I didn't mess up. You were looking at me like I messed up.
Yeah, we definitely were. Let's see what we have here. Yeah, so we'll be talking about the color of the sky with this, Matthew. And we also have Addison joining us today. So, hey, Addison, glad that you're here.
Yeah.
So let's talk about the gas molecules in our atmosphere. We've talked about this before in some of our classroom talks. There's two main gas molecules that are in our atmosphere, and that would be nitrogen and oxygen.
Yeah, and one of them is a lot more prevalent than the other. And it's always been one that it's like you wouldn't think it's more prevalent because you typically talk about the other one, and nitrogen.
Yep.
We have more nitrogen in our atmosphere than oxygen. Remember that.
Right. And, we talked about Saharan dust. So those are a few particles that make up our atmosphere. Right. Water vapor is one of them. So that's about 1%. So water vapor is a big factor when we're talking about humidity and thunderstorms and also the weather going on. But just remember nitrogen, oxygen, and pollution too. Don't want to forget that. So when we have the sunlight, which is made up of all these colors, you have nitrogen and oxygen, which are two main gas molecules in our atmosphere. You have the sunlight reflecting and being scattered. There's that word, being scattered in all sorts of different directions. So this is the answer as to why is the sky blue?
Yeah, so whenever these particles, whenever they scatter the light, they scatter it in such a way that it gives you the color blue on the color spectrum. Now, if you have all the colors together, it shows white light.
Right.
But if you scatter the light, you can sometimes get a rainbow to form. Imagine you scatter that light just perfectly so you only see blue. That's what's going on here.
And it's important to also think about the sun angle. So we typically see the sky blue during the day, right? So it's when the sun is not so low in the sky, like sunrise and sunset. That's when the sun is the lowest in our sky. So think about the sun, at the highest point. And, when you have that scattering with nitrogen and oxygen and those two gas molecules, that's what makes the sky really turn that blue, that beautiful blue.
Yeah, my favorite is whenever you're in the winter and you have that deep blue sky sometimes. Because sometimes you'll have a lack of some other pollution molecules, because sometimes when you have a lot of pollution in the air, the sky can almost appear more white. But whenever you get those deep blue winter days when the air is really clear, that's some of my favorite days. And before we get too deep into the sunrises and sunsets lesson, I also want to hear where your favorite places are to watch the sunrise and sunset.
Ooh, that's a good one. Texas, I mean, the sky is beautiful in Texas.
Yeah, and there's some big sky. Of course, everything's bigger in Texas, and sometimes you can get a big view of the sky.
Yeah.
Especially in places like Enchanted Rock. That's a beautiful place to watch the sunrise.
And it's interesting you were talking about winter and how you have that clear blue sky. We were talking about Saharan and how the heat really contributes to, typically during the summer months, you have the Saharan dust, so you get that, whitish, the hazy skies, right? But you also have the pollution. Ground level ozone is a huge thing in San Antonio, and heat is a huge factor when it comes to ground level ozone. So it kind of goes back to the clear blue sky.
Yeah, and all things that we've talked about on previous lessons. So if you've missed those lessons, don't forget you can watch them on YouTube.
Yeah, so again, it's all pieces with one another, right? So we just like to tie things in and kind of bridge, each topic together. So each color is known as a wavelength, right? Each one has its own wavelength. You have red that has the longest wavelength. We talked about Roy G. Biv, right? So violet actually has the shortest wavelength.
Right. So when you say Roy G. Biv, that's actually in an order. What you see in the rainbow is actually the colors and their wavelength in order. So red, orange, yellow, green, blue, indigo, violet. I'm going to say that over and over just to make sure I say it right.
That's pretty good. See, I would have to write it down.
Yeah.
Like I would know it to write it down for sure. So I'm looking at some of your comments here. We have Brianna White saying, hey, glad that you're joining us today. Matthew says, I'm going to get my mom into Minecraft soon, and I'm so excited. We love that game too.
Yeah, and when the sun goes down in Minecraft, it also causes the light to scatter in different colors too.
Yeah, see, I'm huge into Animal Crossing New Horizons right now, and I just love that game, but you also have pretty sunrises and sunsets. So
yeah, and that game too,
Yeah, exactly. So did you want to take it away on this?
Yeah, I'll take it away. So violet has the shortest wavelength. When light waves of different wavelengths reach Earth's atmosphere, they interact with particles, and that can cause the wavelength to be longer or shorter as it arrives. And so whenever we have a longer wavelength, whenever that sun gets lower on the horizon, we could see that color really change.
Yeah, and we talked about the particles: dust, oxygen, nitrogen, water vapor. You have ice particles because we have high clouds in the atmosphere. So think about cirrus clouds. Some of the sunlight will also reflect off these ice particles. So that's really why the clouds make a beautiful sunrise and sunset here. It's because you have the water vapor molecules, you have the ice crystals in the clouds, and so that will really reflect, a lot of the beautiful colors that we see, like the reds, for example.
Yeah.
We have Sabrina saying, me too, I love Animal Crossing. It's an awesome game. I recently got it, so it's great.
And Addison says hello too. Hello, Addison. I hope you're doing good today.
Yeah, definitely. Okay, so you were talking about how the light waves, when they enter into the atmosphere, they once they reach the atmosphere, they kind of react with different particles. So they're going to be scattered in all sorts of directions. So light waves will bounce in all directions, and this is called scattering. So there's that word we were talking about. And if you're wondering, hey, what's the difference between a long wavelength and a short wavelength, we've kind of laid it out, laid this out for you. So think of like a hill and a valley, right? So when you have, those really short wavelengths, that's, showing the shorter wavelength.
Yeah, there. When the two hills are closer together, that's a short wavelength. When the two hills are longer, that's a wavelength. But you can also, I guess, mark it from the valley. But typically in the scientific community, we typically try to look at it from the peaks. But you can look at it from whenever it takes a full, I guess you could say, rotation. That's not the proper word. I'm trying to grab for the word in my brain.
You've been up for a while.
I did the morning show today, so I've been up for a while. But whenever it takes a full wavelength, I guess you could say, or a full cycle, that's when we count it as a wavelength.
Yeah, definitely. So the sky color depends on the size of the particles compared with the wavelength of light. So that's really something remember that's important there. And we talked about the different particles, but they can also vary in size as well.
Yeah, they really can, and that can cause the light to get scattered in different ways.
So again, remember the word scattering. So red light waves are scattered the least by atmospheric molecules. That's a little fun fact there. And at sunrise and sunset, when the sunlight travels a long path through the atmosphere to reach our eyes, remember at sunrise and sunset, I just mentioned this, our sun is at the lowest point in the sky. Yeah. So it has, sunlight has a lot more atmosphere to get through.
So think about it this way. If the sun is shining, it is okay. Oh,
he's rolled over on his back.
So if the sunlight is shining through the atmosphere, it may only pass through this much atmosphere.
Yeah.
But if it's looking at it from the side, it may pass through this much atmosphere because it's trying to. You have the atmosphere which is curved like this, and then the light has to come all the way through this longer section instead of just a compressed version from straight on.
Right.
I hope that's a good explanation. If y'all have questions, remember, ask them. We're happy to answer them.
Yeah, so remember at sunrise and sunset, the sun, of course, is in the lowest point of the sky, and the blue light has mostly been removed at this point.
And you'll notice that at sunset today, guys, take a look at the sunset today, and you'll see the different colors, and you'll be able to say, oh, yeah, I learned about that today in class.
Yeah. And we have a comment here. Hi from Vivian, who is 5, and Victoria. Vivian loves Animal Crossing too, and so does her aunt uncle. It's an awesome game. I'm glad we have a lot of, Animal Crossing fans here. Yeah. So that's awesome. And we have Ellie joining us too, so I know she's going to talk about it a little bit there.
Yeah.
So blue light has been removed like we were talking about, but red and yellow light will remain. So when the blue light is removed, you'll have the yellow and the red colors and also the orange colors kind of dominate. So that's when you get, that really beautiful cast in the sky that we've seen, especially during sunset.
Yeah, those dramatic sunsets that you may see. Areas like on the coast, when you go to the beach, we always typically see that, and then along some of the lakes. I don't know. It's whenever you have a big open view of the horizon.
Exactly. So this is when we're talking about, sunrise and sunset. The sunlight has more of an orangey and reddish cast, especially in the sky. So remember clouds. Clouds make a beautiful, view for sunrises and sunsets, both of them, because what they contain, the water vapor and also the water droplets, that's when we're talking about water vapor and the ice crystals.
Yeah, and I always say that cirrus clouds, a cirrus deck of clouds, can make for some of the most dramatic sunsets and sunrises, because those cirrus decks, remember, those are ice crystals. We talked about that in another Cloudy with a Chance of Learning lesson. Cirrus clouds are made up of ice crystals, and you can always have such a dramatic sunset or sunrise when that's in the air.
So remember, sunlight, it can be reflected off clouds. It can also be reflected off dust and pollution particles that can actually help enhance the color of the sunset and sunrises too. And so large particles of dust and pollution can make the sky appear gray, like more grayish than blue. We talked about that. The heat plays an important role, especially, when Saharan dust moves in over San Antonio or Texas as a whole. That's typically during the summer months. We have that ground level ozone that we have to worry about. And, heat is a huge factor with that. So when it gets hotter in June, July, really all the way through September, that's when we have that hazy look in our atmosphere.
Yeah. And then once it starts to cool off a little bit into November, December, it starts to not be so hazy.
So again, clouds are a great thing, especially when it comes to seeing the vibrant colors in our atmosphere. So high clouds, like cirrus clouds, will receive the sun's light with little interference from dust or pollution. Remember, when we're talking about high clouds, they're in the high levels of our atmosphere, typically cirrus clouds, right? And that's when it gets really, really cold in our atmosphere. And, the dust and the pollution are well below the cirrus clouds.
Right.
So this is when you get more of that fiery look in the sky with reds and oranges, and it's all due to the ice crystals. You get the scattering, you get the light reflecting, and it's mostly the red light that does the scattering and reflecting off the ice particles in cirrus clouds.
Yeah, and always makes for some of the most beautiful sunrises and sunsets. I always tell people to get the cameras out, because it's going to be a pretty one whenever we have cirrus clouds in the sky.
So when talking about, mid-level clouds, cumulus clouds, for example, even lower clouds that are associated with thunderstorms, that's really going to have more of a grayish look. So it's going to be fighting, the dust particles, pollution, all the stuff in the air. So it's not going to have, as much of a vibrant look. So we like the cirrus clouds.
And there's an old saying, red sky in the morning, sailor take warning. Red sky at night, sailor's delight.
Right.
And so there's a good explanation behind that saying, and it only works for certain areas where storm systems travel from east to west, really. Because when a storm system is coming from east to west, remember our sun rises in the east and sets in the west. So if you have a red sky in the morning, that means that you may have a big cirrus cloud can sometimes be blow off from thunderstorms that are to the west.
Right.
So let's say you have the sun's coming up in the east, but you have a big thunderstorm in the west that's causing some cirrus clouds to blow over your ship if you're out sailing. Well, that sunlight is going to reflect that red, you're going to see that red light reflecting off the clouds overhead, and you're going to say, uh-oh, we may have thunderstorms just to our west. And we may deal with thunderstorms later today because of that if you're out sailing. But then red sky at night, sailor's delight, that means that if you're in an area where storm systems travel from west to east, that means that the sun's setting in the west, it reflects off the red sky because maybe you had some thunderstorms pass earlier on in the day and you'll have a quieter evening ahead of you. So that's a little explanation behind the old saying, red sky in the morning, sailor take warning. Red sky at night, sailor's delight. And
you also can't see it, but Ollie's laying on his back here, and he had his paws raised. So I don't know if he had a question.
Did you have a question, Ollie?
I don't think he does anymore.
No, he took it back. He said, you answered my question for me.
You answered it. All right, let's continue with this. So I just want to show you when we're talking about the color spectrum, when we're talking about Roy G. Biv, right? This is what we're talking about. So you have the shorter wavelengths with the blues and the purples, and then you have the longer wavelengths with the reds and the deep reds.
Right, and this is actually like Vib G. Yor.
Yeah,
because it's kind of backwards.
The
red's on the
backwards,
right. Yeah. But if you read it right to left, rather, it'll be Roy G. Biv because you see the deep red.
Yep.
And then notice the red goes to orange, and then the orange goes to yellow, and then the yellow goes to green, and then the green goes to blue, blue to indigo, indigo to violet. Roy G. Biv. It's just kind of backwards on the spectrum there.
Right. So remember, the sunlight, it looks white to our eyes, but it really consists of all these colors. And, dust, pollution, clouds, ice crystals, water vapor, all this crazy stuff in our atmosphere can contribute to how vibrant our sunrises and sunsets will appear. Remember the two main gas molecules, too. We have nitrogen and oxygen. So, when you have the sunlight reflecting on all these gas particles in our atmosphere, that's why the sky is blue.
Yeah. So now you can tell all your friends and family that the sky is blue because of the scattering of light. It makes it appear blue. Remember that. Always remember that. Because of the scattering of light, that is why the sky is blue.
Yeah. David says, "Oh, I love dogs." We love ours too.
Yeah.
It's every time we talk, when we do Facebook Lives or the classroom talk, he is always whining, and I think he just wants attention. He's
like, well, who are you talking to?
Yeah, I want to be a part of it.
Yeah, Ollie, it's okay.
We would pick him up and show you guys our dog, but
he's a 70-pound Australian Shepherd, so.
Yeah. With questions too sometimes. So, all right, guys. To finish it out, you had a fun day yesterday on the classroom talk.
Yeah,
you talked to the Whitty Museum.
Yeah, we learned a little bit more about Fiesta and their Fiesta exhibit that they have with all the old gowns and old trains from the dresses. Yeah. And we talked about the scepters that they have there, all sorts of fascinating things. And they actually have their medals, their Fiesta medals. You can do curbside pickup with the Fiesta medals. You can order it online, drive up, and they'll bring it out to your car for you.
See, that's cool. I love that. So you had a fun day yesterday with that at the Whitty Museum. Today we talked about sunrises and sunsets. We talked about water vapor today. It looks like we'll dive into that tomorrow. So tomorrow's all about water vapor.
Yeah, that should be a lot of fun at 1 p.m. tomorrow. And then Pets in the Weather on Thursday. Oh, did you hear that?
He has another question.
He does. He's upside down raising his paw at me. But Pets in the Weather, Holly. And then we're going to talk about, we're going to take another field trip to the San Antonio Zoo. Last week, we saw the rhinos and learned about the rhinos at the zoo.
That's cool.
The week before that, we learned about the kangaroos. And then 2 weeks before that, we learned about the giraffes. And I don't know what they have in store for us this next week. Maybe one of the big cats, possibly.
Ooh,
maybe
that's
lions.
Exciting. Yeah.
Anyway, I'm excited for it. Should be a lot of fun.
So make sure to stay tuned. We'll be live on our KINS 5 Facebook and YouTube pages every day at 1 p.m. Maybe Ollie will make his debut on one of these at some point. Again, we'll continue it this month through July. So we're looking forward to it. And if you have any, topic ideas, send them our way. We'd love to see your topic ideas. You can comment on this Facebook Live, our YouTube Live, send us messages or tweet at us. We have Twitters too. So yeah, just send us your topic ideas or any suggestions or comments, and we'll do our best to get back to you on that.
Yeah. And Matthew has a good question. So when it becomes night, the reason the sky turns black because the sun isn't shining light on the part of the earth, right? That's right. Matthew, there's no light to be scattered. And, a good point to make too is that the moon doesn't cast enough light towards the earth to offer enough light to be scattered. So you typically won't see anything. But sometimes when the moon is low on the horizon, get this, when the moon is low on the horizon, it will have the light reflecting off the moon from the sun will have a longer period to travel through the atmosphere. And if you look at that full moon, when there's a full moon on the horizon, you will sometimes see a reddish orangish moon. So just like how the light can be scattered from the sun, the moon can scatter light too, but when it's directly overhead, typically it's not enough light to scatter, and it will still appear white. But the sun, there's so much more light coming off of that. That's why we see the colors of the spectrum scattered and why we will see blue during the day. But at nighttime, you'll just see the stars in the sky.
And Joanne, you talked about earthquakes. Now, we kind of covered earthquakes a little bit when talking about plate tectonics and tsunamis, so you can go back and watch our tsunami video. And if you want us to talk more about earthquakes, we'd be happy to. So we love this stuff. We love geography and astronomy and weather, of course. So send us your sciencey ideas. Let's see if we missed anything. Joanne also saying, thank y'all for these great shows. Hey, thank you so much.
Yeah, no problem.
And glad that you're here. David saying that's cool. And Ellie, of course, saying, I love Animal Crossing. Such a fun game.
Yeah.
All right, Andrew, anything else you want to add?
No, I think that's it. Guys, thank you so much for joining us today. We love doing these talks. And we'll, of course, continue that as we head throughout these next few weeks. We hope you have a wonderful rest of your Tuesday. And don't forget, Weather Chief Bill Taylor will be in at 4, 5, 6, and 10 with the updates to the weather. And you're going to be on during the 4 o'clock show, right?
We'll be doing team coverage. It's all about the tropics. Now that we're done with record heat, we'll be shifting our focus to the tropics now. There are actually 2 areas that we're monitoring. One of them does have a high chance of developing now within the next 48 hours. And you were talking about it on the morning show as well.
Yeah, it could end up being Gonzalo later today, possibly even.
Yeah.
And then the hurricane hunters are going to be flying the system, another system that's near Cuba, possibly this afternoon. They're going to fly it once it comes off Cuba, I'm thinking.
Yeah.
Once it gets further away from Cuba, and they don't have to deal with having to have the issue of flying over land, because the hurricane hunters, they don't typically like to fly over land. They like to kind of stay over water. Once this comes off Cuba, they'll fly this system either this afternoon or early tomorrow morning, and we'll get a better idea of what this system may do and what it's currently doing right now near Cuba.
And not only that, but with the hurricane hunters flying into the tropical systems, we're going to see multiple updates a day. So it's not going to be, one update at 9 a.m. and that's it. I mean, it's tropic season, it's hurricane season, so we're expected to receive multiple updates. I released an update at 9 a.m. this morning, and then we had a newer update, a few hours after that. So it's so important to stay tuned to KINS 5 and also KINS5.com. We'll be releasing, the latest information on these tropical systems. Right now, the first one that's producing showers and thunderstorms near Cuba and also the Bahamas and Florida, that could bring us rain this weekend.
Yeah.
Some much needed rain at that.
By the way, we did Tropics Tuesdays for weeks there, just a few weeks ago, and the hurricane hunters were one of the topics. You can go back and watch that on YouTube. Just search it, and especially within our playlist, it'll be easy to find it there. You'll find our topic on Tropics Tuesday, the hurricane hunters. Be sure to check that out. That was a fun one. Something I'm really passionate about and really interested in are those men and women that fly the storms, and it's a cool topic. But guys, we're going to go ahead and sign off of here. We hope you have a wonderful rest of your day.
See you later.